This lesson works on using models to draw pictures that represent multiplying polynomials. So the first example asks us to draw a picture to represent x plus y plus 4 times the quantity y plus 3. And what we're doing is we're drawing an area model, basically. So now we've taken it from drawing a simple area model with just numbers to drawing an area model using variables. So basically we need to draw a big rectangle. And then we need to label the sides. We have x plus y plus 4, so we can partition this into 3 values, x, y, and 4. And we can partition the other one into 2 values, the quantity y, which is probably about that big, and the quantity 3. Now we can multiply, because if we have just created a length of x plus y plus 4 on the length, and on the width we've created a width of y plus 3. And to find the area, we multiply the length times the width. So for this first rectangle, and I'm just numbering the rectangles so that you'll know which one we're working on. The first one has a width of y and a length of x, and x times y is xy. The second square has a width of y and a length of y. So it is y squared. And if you notice, it's a square. So we have two sides that are the same length times each other, it would be y squared. And then the last square, number 3, is 4 times y, or just 4y. Then we go down to the next couple rectangles. We have a width of 3 and length of x, so you're going to have 3x. In rectangle 5, you're going to have a length of y, a width of 3, so you'll have 3y. And in the last rectangle, you'll have a length of 4 and a width of 3, which is just 12. Now, the next question asks to write an equivalent expression using the distributive property. So we have drawn a model, and now we want to use the distributive property, which is what we've essentially done using the area model, to write out an expression. So we have to look first for like terms. In box 1, we have xy, and then we look to the other box and say, are there any other terms that have xy, and then we can add with it? And the answer is no. So as I do it, I kind of cross it off so I know I've used it. So my first term will be xy. My second term, I look to the second box, and I have a y squared. So then I look to the rest of the boxes. Are there any y squareds to combine it with? No. So I'm going to add y squared to the xy. Then I look to box 3, and I see that there is 4y. So I look for any other y terms, and I see it down here in box 5. So 3 and box 5 can be added together. So 4y plus 3y gives me 7y. So I've used those two. Then I can look at the last remaining boxes. I have just a number, and then I have a term using an x. So I can add on 3x and 12, and those cannot be combined because they're not like terms. And that is as simple of an expression as I can write, not knowing what x and y are.